the laws of motion. But firstly, I need to tell you that if you want to learn about laws of motion, then you must have the knowledge of force. And for force, the external cause, I have already told you that what is force. You must watch the video, that is force 1, that is in the our channel already. So if you watch that video, then you will get the idea of force. What is force? What is the SI unit for it? What is the type of force that can be possible? That is contact and non-contact forces. So watch the video force 1 before you come to learn the laws of motion. So now I am directly coming to the topic, that is about laws of motion. In laws of motion, Newton's laws of motion, basically there are 3 laws of motion. So in this part, in this section, we will get to learn about the Newton's first law of motion. What is it? Before coming to the first law of motion, I'll give you some examples. Suppose that here I have the pen that is placed over my palm. Is it going to move anywhere unless I apply the external cause, the force to the body, to the marker? No, obviously not. As you can see here, it is just placed on my palm and it is not going anywhere, it is not moving. Why so? Because I am not applying the force to it, I am not applying the external cause to it. So if the body is at rest, it will tend to be at rest, it will remain at rest only. Why? Because we are not applying the force on it. And suppose if a body is moving on a straight line path with some speed, suppose that the speed of the body is 20 km per hour and the body is moving on a straight line path, then unless we apply an external force to the body, it won't change its state of motion. It will continue to move on the same straight line in the same direction with the same speed unless we apply the external force. And if we are applying the external force to the body, then it might be possible that the direction of motion, it might be changed from this direction to this direction or this direction, or it also might be possible that the speed of the body increases or decreases. So this is both the cases, that is the state of rest or the state of motion. If the body is at rest, it will continue to be at rest. If the body is in motion, it will continue to be in motion with the same speed and in the same direction unless we apply an external force to it. So now we are coming to the first law of motion. I'll read it for you. What does it state? It states that if a body is at rest, it will remain at rest, or now we are talking about the state of motion, or if a body is in motion, it will continue to move. It will continue to be in motion with the same speed and in the same direction unless an external force is applied to it. I think it must be very clear to you. It is the Newton's first law of motion and it is also known as law of inertia. I'll write it over here. It is also known as law of inertia. So firstly, let me tell you about inertia. You must have heard about this term inertia. What is inertia? Firstly, let us know about inertia. I'll write it over here. Basically, it is the property, it is the inherent property of any body due to which it tends to maintain its state of rest or its state of motion. I'll explain it to you with the help of this example only. Suppose I am talking about this board. I apply some force on the board, but is it moving? Does it comes to the state of motion? Does it start to move? No, it doesn't move at all. Why so? Because it has the tendency to be at rest. It has the tendency to be in the same state, in the state of rest. Why so? Because it has some mass. Now basically inertia, it is due to the mass of the body. If there is no mass, if there is any body, then it must have some mass. And if has some mass, then it must have some inertia. Suppose that this pen, it is kept over here, it is placed over my palm and I want it to move. Then what do? I apply some force to it and it starts to move. It means that it has less inertia. But I am applying some force on the board, but it is not going anywhere. It is not going to move. Why so? Because it is hung, it is suspended on the wall, and obviously the wall, it has very much greater mass. So if it has very much larger mass, then it will have much inertia. larger inertia, and so it has the larger tendency to be at the same state, to be in the at the state of rest. Suppose we are talking about a bike and a truck. The bike, suppose if you have to stop a bike or you have to push a bike, then you apply some force and it starts to move. But is the condition same for the truck? Obviously not, because if you apply some force to the truck, it has very larger mass, and in that case the inertia is also greater. So if we want the truck to move, we have to apply a larger force to move it. To 20 or 30 men, it might be possible that when 20 or 30 men they are pushing it, they are applying force on the truck, then it might be displaced, it might move. So basically, what is inertia? It is the inherent property of any body by the virtue of which it tends to maintain the state of rest or of uniform motion. Now keep it in mind, whenever I use this term uniform motion means, here I have written that it will continue to move with the same speed and along the same direction. I think it must be clear to you. Earlier in the last chapter you got to know about uniform motion, uniform speed. It means that the body is moving with the same speed along the same direction. So if what does it state? What is inertia? It is the inherent property. Inherent means of its own, possessed by the body. It is the inherent property of any body, due to which, by the virtue of which, or due to which it tends to maintain the state of rest or of uniform motion. It's very simple. We use this term uniform motion for this statement. The body, it will continue to move with the same speed and along the same direction. That is, the body will continue to move with uniform motion. It will be in uniform motion. So if the body was at rest, it will continue to be at rest. If the body was in motion, uniform motion, then it will continue to be in the uniform motion. So this tendency of the body, it comes from the property, the inherent property, that is inertia. Now, as I told you, if the mass is greater, the inertia would be greater. If the mass is larger, the inertia would be larger. And I gave you the examples also of the bike and the truck. If you want the bike to set the bike to motion, into motion, then what do? We apply some force to the bike and it starts to move. But that is not the case in the truck. If you want the truck to be moved, to set into motion, then you have to apply a larger force. It means that larger mass, larger inertia, lower mass, smaller inertia. So if whenever you think about mass is nothing but it is the mass is the measure of inertia. Mass is the measure of inertia. Now, as I told you, if the mass is larger, the inertia is larger. If the mass is smaller, the inertia is also smaller. So now you got to know about inertia, and this, the first law of motion, it is also known as law of inertia, because if you are not going to apply any external force on the body, then it will continue to be in the state of rest or in the state of motion, that is in uniform motion. Now, as you know about inertia, I told you about inertia. According to the definition of inertia, what was it? It was the tendency of the body to maintain its state of rest or its state of motion. So on the basis of that definition only, we have two types of inertia. That is the inertia of rest or the inertia of motion. So firstly, we will be talking about the inertia of rest. What is it? What is inertia of rest? Let us define it. Again, the same part. It is the inherent property. Inherent means possessed by the body. It is the inherent property of any body by the virtue of which or due to which it tends to maintain the state of rest. So it's very simple. What is the inertia of rest? It is the property, it is the inherent property of any body by the virtue of which, due to which, what is the tendency of the body? The tendency of the body is to maintain the state of rest. Now let us have some example. Suppose I gave you the example of the bike and the truck. If you are going to apply some force on the bike, then after some interval of time you might notice that it starts to move. It has been displaced. But in the case of the truck, if you apply some force on the truck, then is it going to move anywhere unless you apply a much larger force to it? No, it won't move anywhere. Why so? Because the truck and the bike both have the tendency to maintain their state of rest. Now suppose you are exerting the force to the truck. So we have the tendency to move it. But the truck has the tendency to resist the change. To resist the change means we wish that the truck should move, but what is the tendency of the truck? It tends to be at rest and not to be in motion. So it resists the change. It tends to maintain its state of rest. But if you apply much larger force to the truck, then we overcome the resistive force, we overcome the inertia, and that is why the truck, it starts to move in any direction in which you are applying the force. So basically, what is the inertia of rest? You got the idea. The body has a tendency to maintain the state of rest. But if you apply much larger force, then the body, it will start to move. If it is at rest, it will start to move. So this was about the inertia of rest. I'll give you some examples to make it more clear. Suppose I have this glass, and along with this glass I have a coin and a sheet, a card. Suppose I place this card over this glass, at the top of the glass, and over this card I place a coin. I place this coin over this card. Now what I am going to do, look for it. I will apply some force on the card. I will apply some force with the help of my finger on this card. Then obviously, as you know, force, what is force? It is the external cause that can change the state or state of motion of a rigid body. So obviously it is a rigid body and I am going to apply the force on it. So obviously now it is at rest, but when I apply the force on it, it must move. So I apply the force on it. What do you observe here? I applied the force on the card and obviously it is set into motion. It was at rest, but as soon as I applied the force, it started to move. But what about the coin that I placed over the card? The coin, it falls down. It goes inside the glass. Why so? Think about it. I applied the force on the card and that is why it was set into motion. But I didn't apply any force on the coin directly. So it has the inertia of rest. The card, the base above which the coin was placed, it was set into motion. But what is the tendency of the coin? It was at rest, and as I told you, what is the law of inertia? What is the Newton's first law of motion? If you are not applying any external force to any body, it will tend to maintain its state of rest or of uniform motion. So I didn't apply any force to the coin, and so according to Newton's first law of motion, the coin will have the tendency to maintain its state of rest. So it was at the same position, it was at rest, it maintained its state of rest, but the base below it, the card below it, it was set into motion, it moved, and that is why the coin, it fall inside the glass. So I think with the help of this example, it must be very clear to you. I'll give you some more examples for it. Suppose after the winter days are over, your mother, she asked you or your brother to clean the blanket. To clean the blanket, it means that what do you do for that? One of your brothers, you or your brother, he holds it, and you have something in your hand, a stick or a wicket, and you start to beat the blanket in order to clean the blanket so that the dust, it might get away from the blanket. What do? You apply the force with the wicket or the stick, and you are applying the force directly to the blanket. So as the blanket, it is experiencing force, so it starts to move. It moves in some direction. But what about the dust particles that were settled on the blanket? You didn't apply any force directly on the dust particles. As a result, the dust particles, they will have the tendency to remain at the state of rest, in the state of rest, due to laws of motion, Newton's first law of motion. So what do we conclude here? You apply the force, suppose this is the blanket, you apply the force with the help of stick or wicket on the blanket. As a result, the blanket, it shifts in this direction, backward direction. But what about the dust particles that were settled on it? As the blanket moves in this direction, but the dust particles, they have the tendency to maintain their state of rest. As a result, the blanket is here presently, and the dust particles are left here only due to the state of rest, due to the inertia of rest. As a result, the dust particles, they settle down. So with the help of these examples, it must be clear to you that what is inertia of rest. In the next part, we are going to talk about inertia of motion. Now we will talk about the inertia of motion. As the term sounds, motion, inertia of motion, it means that the body, it must be in the state of motion. So what is it? What is inertia of motion? You can define it of your own. Inertia of motion, the inherent property. What is it? It is the inherent property of any body by the virtue of which it tends to maintain the state of motion. And as I told you, if you are not going to apply any external force on the body, then it will continue to be in the state of motion. But with what? In the state of motion with the same speed and in the same direction. And in the same direction. You can also use the term directly, that is, the body will maintain its state of uniform motion. Or you can write over here with the same speed and in the same direction. I hope so that up till now you must have the idea that why are you using this statement. Or we can write over here, instead of writing this, we can write over here directly that the body maintains its state of uniform motion. So what is it? What is inertia of motion? It is the inherent property of any body by the virtue of which or due to which the body tends to, it has a tendency to maintain the state of uniform motion. Uniform motion, or you can write over here, it has a tendency to maintain the state of motion with the same speed and in the same direction. So it is about inertia of motion. Now I'll give you a simple example so that the concept about inertia of motion, it would be more clear. Or it might be possible that you are asked in your examinations that suppose that we are advised whenever we want to come out of the train, of a running train, then we are advised not to do so. And you have earlier, you must have seen the vendors that whenever they need to get out of the train, firstly they run up to some distance along with the train in the direction of motion of the train. They continue to run with the train only, and then after they can go wherever they want to go, they can get out of the train. But if you are asked that why do they do so, what is the reason behind that? That is inertia of motion. Now I'll explain it to you. What is about the inertia of motion in this case? Suppose you come out of the train, you jump out of the train. Suddenly, all of a sudden, you jump out of the train. What is the condition there? As soon as you jump out of the train, out of the running train, what is the case there? The lower part, your legs, the lower part of a body, as soon as you jump out of the train, the lower part of your body, the legs, they come to rest instantly. As soon as they come in contact with the earth, your lower part, the legs, they come to rest. But what about the upper part? The upper part, it is still in the direction of motion with the train. What is the reason behind that? That is inertia of motion. As I told you, the train is moving, along with the train we are also moving. But all of a sudden, if we jump out of the train, then what is the condition there? The lower part of our body, the legs, they instantly come to rest. As soon as they come in contact with the earth, the lower part of our body, the legs, they come to rest. But the upper part, it still has a tendency, because no force is being applied on the upper part by the ground. So what does happen here? Due to inertia of motion, the upper part of our body, as no force is being applied to it directly, the force is being applied to the legs, to the lower part, and as a result they come to rest instantly. But the upper part, it is not experiencing any force, and that is why it will tend to maintain its state of rest in the same direction, that is in the direction of motion of the train. And as a result, the lower part, it comes to rest, but the upper part, it tends to still to be in motion, in the state of motion. As a result, we fall down. So I think that with the help of these examples, your concept of inertia of rest and inertia of motion must be clear.